Most people are familiar with the formula a is equal to pi times r squared for finding the area of a circle. While there are many ways to prove this formula, one of the more interesting ways involves transforming a circle into a triangle. While it may sound complicated, the mathematics behind this concept are surprisingly simple. Before we start, I want to make it clear that the proof I'm about to show you isn't an original idea of mine. It draws inspiration from the concept of indivisibles, which is a mathematical principle proposed by the Italian mathematician Bonaventura Cavalieri. This principle involves looking at geometric figures as if they are composed of an infinite number of tiny indivisible elements. To explore how we can use indivisibles to find the area of a circle, consider a circle that could unravel. Notice how the circumference of the circle unravels to the same length as the red line. Since the circumference of a circle always equals twice the radius multiplied to pi, the length of the red line must also equal the same. Now, based on Cavalieri's principle of indivisibles, the interior of the circle can be decomposed into layers of smaller circles that, when taken as a whole, would be equivalent to the original shape. For simplicity, we'll use 8 concentric circles. If we unravel each of these circles one at a time, beginning with the outermost layer, and lay them in order, we begin to form a triangle since the circumference of each interior circle gets smaller and smaller as you approach the center. It is clear that the base of this triangle is 2 times r times pi. Remember, that was the circumference of the outer layer. And the height is equivalent to the radius of the original circle. These two parameters are precisely what we need to calculate the area of a triangle, since the area of a triangle is equal to the product of the base and the height divided by 2. Substituting 2 times r times pi as the base and r as the height gives us an equation as shown. Dividing out the 2's and multiplying the r's leads us back to the familiar formula a is equal to pi times r squared. So by peeling back the layers of a circle, much like an onion, and using Cavalieri's indivisibles, we've proven that a circle is no different than a triangle. Thank you so much for joining me, and please share and like for support.